briefly talk about RMS values. RMS means root mean square. Okay, the root mean square value of an AC current is the value of DC current that will dissipate the same amount of power as AC current on a resistor. We have AC dissipating power, so we are looking for a DC current that will give us the same amount of power that the AC current is dissipating on this particular resistor. Once we're able to find that DC current that gives us the same amount of power that an AC current dissipates on a resistance R, then we can call that our DC current. Okay, so the above definition is based on the principle of equating the heating effect of current calculated in both sides. Okay, so dissipating would means that you're losing, energy, you're losing power, you're losing heat to the environment in form of you're losing energy in form of heat to the environment. So first, you calculate the power dissipated in the resistance in the DC circuit as shown in this right hand side here. All right, so what you can see here, our VR, if you want to find this VR, will be equal to current passing through this R multiplied by the R. So you can see the current is IDC. Okay, if this is voltage, this voltage is a DC source. So you see IDC multiplied by R gives us our VR, as you can see here. Also, you can go ahead and say, since we have our VR, you can say our PDC, which is going to be power dissipated on this resistance here will be equal to VR multiplied by IDC, because power is VR, all right? And we do know that our VR is already R multiplied by IDC. So if you combine these two together, your PDC will be equal to R IDC squared. Now this is an equation you're already familiar with. It's nothing strange about this equation, because we've talked about the fact that power is equal to I squared R before. In this case, we're talking about the voltage, we're talking about IDC because the voltage source is in DC. So you can see that the PDC, or direct current power, would be equal to IDC squared. Okay, so if we take it a step further, what we do have here would be VR. If you are not going to calculate the power dissipated in the resistance in the AC circuit, this is not what is going to happen. When we talk about AC, we're talking about time. We're talking about time in current with respect to time, voltage with respect to time, and so on and so forth. Okay, so what you have is our VR of t would be equal to I of t multiplied by R. So that is how to find the voltage across the resistance in an AC circuit. So VR of t, because we have a time varying waveform here. So we have VR of t would be equal to I of t multiplied by R. So AC power would then be equal to V of t multiplied by I of t. We know power is equal to VI under normal circumstances, as discussed earlier. So if you combine these two together, what you would have here is PAC would be equal to R multiplied by I of t squared. All right. And our I of t is usually given as our I max sine WT. Okay, W is our angular frequency, and then you can see we have WT here. You can see we have time here. So, and I max represents the maximum, the amplitude, the maximum current that we have. That's I max. So what you have here, instead of writing I of t here, we know our I of t equal to I max and WT. So if you squared I of t, that gives you I squared. That will give you I max sine WT squared altogether. That is I squared of t. Don't forget, I of t would also be equal to V max over R, by the way. I of t would be equal to V max over R. So if you put that here and you square it, you're going to have V squared max over R squared. That gives us our I max squared, by the way. Sorry. So I max is going to be V max over R. Okay. So you can just replace that and put I max here. So you can see you have the power in the AC cycle equal to R multiplied by I max sine WT squared. Okay. So in this particular circuit, this is what you have when we're talking about the AC circuit. You can see we have V of t here. In the DC, it's just going to be V, all right? But in an AC, you have V of t because the time varying waveform. You have I of t, and then you have VR of t. So your VT is V max sine WT for these, and then your I of t will be V max over R sine WT. So let's pay attention to these two equations and keep them somewhere, because we'll use them for some of the calculations we're talking about. And our I max will certainly be equal to V max over R. I max will be equal to V max over R. Angular frequency is always equal to 2 pi f, where f is going to be the frequency, and then you know pi, you know 2. And then if you know time, you can easily find sine wt, and then you can find I, or you can find b, depending on what you're looking for. So we've talked about this P power, the DC power would be equal to R IDC squared, and then AC power would be equal to R I max and WT squared, and all of this. So we're just putting all of this together to, crystallize, what we just talked about. Okay, let's go ahead. So we've talked about this definition too. RMS value of an AC current. RMS value, which means square value of an AC current, is the value of DC current that would dissipate the same amount of power as AC current on a resistance. So we talked about all of this before. And then we said I squared of T equal to I max sine WT squared. And then our IRMS will then be equal to 1 over T, where T is the period. Okay, 1 over T integral of I of T squared dt. Okay, so this is going to be our IRMS, the root mean square current. Okay, that we have. So pay attention to these two, 1 over T integral of I of T squared. And the reason we have this particular, RMS is that for sinusoidal signal, RMS value simplifies to the amplitude divided by 2 raised to power 1 over 2. Don't forget, 2 raised to power 1 over 2 will be the same thing. Okay, it will be the same thing as square root of 2. Okay, so if we are saying that for sinusoidal signal, RMS value simplifies to the amplitude, or amplitude divided by 2 raised to 1 over 2, it simply means that we are saying our IRMS can be equal to, amplitude is usually referred to as the maximum value. So you can say our I max, right, all divided by I max over root 2. That is what it simply means, over root 2. That's what it simply means, okay? Or you can say your VRMS, all right, will just be equal to V max, which is the amplitude, right, all divided by root 2. Okay, that is what this means. For a sinusoidal signal, RMS value simplifies to amplitude divided by 2 raised to power half, where 2 raised to power half simply means the same thing as square root of 2. Okay, so here is a simple question that we can probably just check out and try to see how this applies to some of the things we've been talking about. Calculate the RMS value of the sinusoidal voltage waveform with 312 volt peak value as shown on the right hand side. So the amplitude in this case, amplitude voltage in this case is going to be 312. So V max is 312. That's why they call it voltage peak, or peak voltage, or the peak value of the voltage. Then VRMS will be equal to V max, like we said, divided by square root of 2. So that will be equal to V max times 0.7071. 1 over square root of 2 is 0.701, by the way. So you have V max times this, and that gives you 220 volts. Where is 220 volts on this graph? This is where it is on the graph. Okay, so your VRMS is going to be equal to 220 volts, and then your peak value will be equal to 312 volts. Okay, the amplitude value of the AC current, AC voltage is 312, and then your V RMS will be 220 volts. Okay, so in Turkey, domestic RMS is going to be 220 volts, and not only in Turkey, in most of the countries, I know that the domestic RMS voltage level is, we call it 220 volts. Even in Cyprus, that we are in here,